Hello students, hope you all are fine and healthy. We are reading chapter number 2 is matter around us pure. We are learning the different separation techniques that are used to separate the different kinds of mixture. Today we will learn how can we separate different gases from air. So we can separate the different gases from air by fractional distillation. We can use fractional distillation. Fractional distillation is used to separate the mixture of two or more miscible liquids that have a difference in their boiling point less than 25 Kelvin. It is used to separate two or more miscible liquids which have a difference in their boiling point of less than 25 Kelvin. Less than 25 Kelvin. So fractional distillation उन miscible liquids को सेपरेट करने के लिए यूज करते हैं जिनके बॉइलिंग पॉइंट में डिफरेंस 25 केल्विन से लेस है. द apparatus that is used for fractional distillation is similar to the apparatus used for distillation. Apparatus is similar to the apparatus that is used for the simple distillation. For fractional distillation, a fractionating column is fitted between the distillation flask and the condenser. A fractionating column is fitted between the distillation flask and the condenser. What is this fractionating column? Fractionating column is a long vertical glass tube. It is a long vertical glass tube that is having glass beads inside it. It is a vertical glass column or glass tube that is having glass beads inside it. Glass beads inside it. So what is the use of these glass beads inside the fractionating column? The glass beads provide a large surface area for cooling the hot vapors and condensing them. It provides large area for cooling hot vapors and condensing them. The fractionating column has different temperature zones inside it. The highest temperature is at the bottom and the lowest temperature is at the top. It is having different temperature zones. The highest temperature is at the bottom of the fractionating column and the lowest temperature is at the top of the fractionating column. We know that air is a homogeneous mixture of different gases like nitrogen, oxygen, carbon dioxide, helium, argon, etc. Air contains 78.03% nitrogen, 20.99% oxygen, 0.93% argon and other gases are in 0.05%. These gases can be separated from each other by the fractional distillation of air. When these gases are in liquid form, they have different boiling point. They are having different boiling point when they are in liquid form. Liquid air is an extremely cold substance. It is an extremely cold substance and when the liquefied air is warmed during fractional distillation, they boils at different temperatures and these gases are collected at different heights in the fractionating column. They are collected at different heights. In the fractionating column. So let us learn the process used for the fractional distillation of air. In the first step, the dust is removed from air. In first step, dust is removed, and after the removal of dust, carbon dioxide and water vapors are also removed because they will freeze during the cooling of air. So the water vapors and carbon dioxide are removed because they will freeze during the cooling of air. For liquefying air or for converting the air in its liquid form, the air is compressed to a very high pressure and then it is cooled. Air is compressed and cooled for liquefying. For cooling it more, the air is allowed to expand. For cooling the air further, it is allowed to expand. Process of compression, cooling and expansion is repeated again and again until the air gets so cooled that it converts into liquid air. The compression, cooling and expansion, they are repeated again and again, and expansion are repeated again and again until the air gets so cooled that it converts into the liquid air. Then the liquid air is warmed in the fractionating column. The liquid air is warmed in fractionating column. The liquid nitrogen gas has a boiling point of minus 196 degrees Celsius. So it boils first and converts into nitrogen gas. The liquid nitrogen is having a boiling point of minus 196 degrees Celsius. So it boils first. And converts into nitrogen gas. This nitrogen gas is collected from the top part of the fractionating column. The liquid argon has a boiling point of minus 186 degrees Celsius. So it boils after nitrogen and converts into argon gas, and it is collected from the middle part of the fractionating column. After nitrogen, liquid argon boils at minus 186 degrees Celsius and it converts into argon gas, which is collected from the middle part of fractionating column. Liquid oxygen has a boiling point of minus 183 degrees Celsius. The liquid oxygen has a boiling point of minus 183 degrees Celsius. So it boils at last and it is collected from the bottom part of fractionating column. It is collected from bottom part of fractionating column. This flow chart shows the different processes that are involved in obtaining the different gases from air by fractional distillation. So first the air is compressed, cooled and expanded. This process is repeated again and again until the air gets liquefied. Then the liquid air is formed in the fractionating column, and the nitrogen, which is having a boiling point of minus 196 degrees Celsius, it boils first and converts into nitrogen vapors or nitrogen gas, and it is collected from the top part of fractionating column. Argon is having a boiling point of minus 186 degrees Celsius. So after nitrogen, the argon boils and converts into argon gas. The argon gas is collected from the middle portion of the fractionating column. And the oxygen, which is having the highest boiling point of minus 183 degrees Celsius, it boils at last. It is collected from the bottom part of fractionating column. So this is the process that is used for separating different gases from air by fractional distillation. So that's it, students. In case if you are having any doubt, please write it in the comment box. Thanks for watching. Bye bye. Take care.